Hi, this is Professor Sartor, and I'm going to be working 10 problems from my college algebra course. The first question says solve, and the type of equation we have is a linear equation. -4 times 6 minus x plus 6 equals 10 minus 6 times x plus 2. So when I solve an equation like this, I want to first make each side as simple as possible. We make it as simple as possible by getting rid of parentheses and combining like terms. So on the left, I'm going to use the distributive property and distribute -4 to each term inside the parentheses. That gives me -24 plus 4x. I'm going to carry down the plus 6. On the right-hand side of the equation, I'm going to distribute the -6 to the terms in the parentheses. That gives me -6x minus 12. Then I'm going to combine like terms. So on the left, I carry down that 4x and combine the like terms to get a -18. And on the right, I'll carry down the -6x and combine the like terms to get -2. Once I've made each side as simple as possible, I want to get all the x's to the same side. So I would add 6x onto both sides. That would give me 10x minus 18 equals -2. And once I have all the x's on the same side, I want to get x by itself. I'm going to add 18 to both sides. That gives me 10x equals 16. Divide both sides by 10. I can reduce 16 over 10 to be 8 over 5. So the solution is 8/5. This question says solve the following rational equation. 2 over x plus 1 plus 1 over x plus 12 equals 7 over x squared plus 13x plus 12. This is a rational equation because we have variables in the denominators. We're going to start by finding the restrictions. You can find the restrictions by setting the denominator equal to 0. So our first denominator is x plus 1. We'll set that equal to 0 and get x equals -1. So for my first restriction, it's x is not equal to -1. Because if x is equal to -1, that means this denominator would equal 0, and dividing by 0 is undefined. So then I'll take my next denominator, x plus 12, set that equal to 0, and solve. I subtract 12 on both sides and get x equals -12. So that's my next restriction. So if x were equal -12, then this denominator would be 0 and dividing by 0 is undefined. So then I'll take that last denominator, x squared plus 13x plus 12 equals 0. This is a quadratic equation. I'll solve by factoring. So these two terms need to multiply to be x squared. So that's going to be x and x. Then these two terms need to multiply to be 12. So some factors of 12, 1 times 12, 2 times 6, 3 times 4, but I'm going to use 1 and 12 to create that middle term of 13. Sorry, that my highlighter wasn't working there. So our factors are x plus 1 and x plus 12. So once we have it factored, we set each factor equal to 0. And we subtract 1 on both sides to get -1, subtract 12 on both sides to get -12. And you can see that these are the same restrictions that we already have. so we don't need to add to our list. So now we're going to get to solving. The way we solve this rational equation is with a method called clearing fractions. So we need the least common multiple. The least common multiple of the denominators, we're going to take each factor in the denominator to create the least common multiple. So we'll go one at a time. We need a factor of x plus 1 in my least common multiple. We need a factor of x plus 12 in my least common multiple. And then we've already factored that denominator right here. We already have the factor of x plus 1, and we already have the factor of x plus 12, so I don't need to add to that. Now what you're going to do with these least common multiples, let me rewrite the problem first. 2 over x plus 1 plus 1 over x plus 12 equals 7 over, and I'm going to use the factor form here, x plus 1 times x plus 12. So what we're going to do with that least common multiple is we're going to multiply every term by that least common multiple. We're basically multiplying the same value on both sides of the equation. So we're multiplying by the least common multiple here, x plus 1 times x plus 12. We're multiplying it here, x plus 1 times x plus 12. And we're multiplying it here, x plus 1 times x plus 12. Then, the reason why this method is called the clearing fractions method is because the least common multiple is going to cancel out all of the denominators, clearing the fractions from the problem. So we're canceling out those common factors, and what's left is 2 times x plus 12 plus 1 times x plus 1 equals 7. From here, I'm going to get rid of the parentheses with the distributive property. That's 2x plus 24 plus x plus 1 equals 7. Then I'll combine like terms. 2x plus x is 3x. 24 plus 1 is 25 equals 7. I'm going to subtract 25 on both sides. That gives me 3x equals negative 18. Divide both sides by 3, and I get x equals negative 6. Now the last thing that we need to do is compare, sorry, my highlighter stopped working again. Compare our answer that we got of x equals negative 6 to the restrictions that we had before. And as long as it doesn't match, we have the solution to the equation. And since it doesn't match the restrictions, that is what our solution is. X equals negative 6. This question says, write the corresponding algebraic expression or equation for the verbal statement. Let x represent the unknown number. Our statement is the quotient of 4 and 5 times a number. So let me highlight one word here, the quotient. Quotient means division. And then the quotient is going to be a quotient of two things. So the quotient of 4 and 5 times a number. So those are the two things that we're dividing. The number 4 and 5 times a number, or 5x. So we can write 4 divided by 5x, or in fraction form, 4 over 5x. This question says, solve the following equation by factoring. 6x squared minus 31x minus 30 equals 0. So this is a quadratic equation because we have the x squared there. And the directions want us to solve by factoring. So in order to solve by factoring, I need factors of 6 and factors of 30. The factors of 6 are 1 times 6 and 2 times 3. Factors of 30 are 1 times 30, 2 times 15, 3 times 10, 5 times 6. I think that's all of them. And so let's set this up. We want to factor 6x squared minus 31x minus 30. I'm going to set up two parentheses. The numbers that go here and here need to multiply to be 6x squared. The numbers that go here and here need to multiply to be 30. So I'm using a method called the guess and check method or the trial and error method. And we're going to take combinations of the first factors and the second factors and put them together until we get the right one. Trial and error, guess and check. So I'm going to start with my first pair. So that's x and 6x, 1 and 30. And when we check this, I am only going to be checking the inside and the outside because the way that I've worked this out, I've kind of guaranteed that the first part will work. Well, let me just show you so that it makes sense. If I were to multiply this out, I would get a 6x squared, a 30x, a 6x, and a 30. So can you see that the first term matches the first term and the last term matches the last term? The only thing that might not be right is the middle two. You're going to think of either adding or subtracting. If you add these two, you would get 36. If you were to subtract these two, you would get 24. Either one of those are wrong. We want to get a 31 in the middle. So this is not a good guess. So we're going to move on and try another guess. Let me set up my two parentheses again. And I'm going to use the same numbers, but I'm going to switch the order. So have x and 6x, and I'm going to put the 30 here and the 1 here. Now I'm only going to check the inside and the outside. Hopefully you believe me about the first one and the last one being right. So if we do the outside, we get x. If we do the inside, we get 180x. 180x, 180x plus x is 181. 180x minus x is 179. Those are both wrong. Okay, so now we've eliminated that pair going together. So we'll try another pair. So I'm going to move on to now trying 1 and 6 with 2 and 15. So I have x and 6x and 2x and 15. Only checking the inside and the outside would give me 12x and 15x. If you add those, 12x plus 15x would give you 27x. 15x minus 12x gives you 3x. Neither one of those are the 31 that we need. Okay, so let's try another one. X, 6x. I'm switching the 15 and the 2. The inside and the outside. Let's see, 15 times 6 is how much? 15 times 6x is 90x, and 2x, and that's not going to give us the 31 that we want. Okay, so let's try another one. So now I'm going to try 1 and 6 with 3 and 10. 3 and 10. Inside is 18x, outside is 10x. 18 plus 10 would be 28. 18 minus 10 would be 8. That doesn't work. Let's try another one. So I'm switching up the 10 and the 3. Inside 60x, outside 3x. That's not going to give us 31. All right, so now let's try 1 and 6 with 5 and 6. I have x times 6x and 5 and 6. Inside would be 30x, outside would be 6x. Nope. Okay. X and 6x. We've got the 6 and the 5. That gives me 36x and 5x. So 36 minus 5 would give me the 31. So I need it to be a negative 31. So I'm going to make this one negative to make a negative 36, and this one positive to make a positive 5x. So that's going to be my correct factorization. Let me erase some of this mess. Okay, so we have now figured out the factorization for 6x squared minus 31x minus 30 to be x minus 6 times 6x plus 5 equals 0. Now we're going to set each factor equal to 0 and solve. Add 6 and get 6. Subtract 5. 6x equals negative 5. Divide by 6. We have x equals negative 5, 6. Those are our two solutions. This question says, solve the following quadratic equation using the quadratic formula. 4x squared minus x plus 7 equals 0. Our quadratic formula, we have ax squared plus bx plus c equals 0. The solutions to that quadratic equation are negative b plus or minus the square root of b squared minus 4ac all over 2a. So for our example, we have 4x squared minus x plus 7 equals 0. A is the coefficient of the squared term, which is 4. B is the coefficient of the x term, which is negative 1. And C is our constant, which is 7. We'll substitute these values into the formula. X equals negative b, and b is a negative 1, plus or minus the square root of b squared minus 4 times a times c all over 2a. Okay, so I've got the formula written out. I'm going to simplify using order of operations. I would have 1 plus or minus. Negative 1 squared is a positive 1. And then I've got 4 times 7, which is 112 over 8. 1 plus or minus square root of negative 111 over 8. And now I want to simplify the radical because I have a negative inside the radical. This is going to become 1 plus or minus I square root of 111 over 8. If you can, you want to try to simplify that radical, but 111 is prime, so that's going to be our final answer. 1 plus I square root of 111 over 8, and 1 minus I square root of 111 over 8. This question says the sum of the square of a positive number and the square of 3 more than the number is 17. What is the number? The positive number is blank. So in this question, we want to translate this sentence into math symbols, into an equation. So we have the sum, which means that we're going to add some things together. And the things that we're going to add together are the square of a positive number. We have that word and, it separates these two things. The square of 3 more than the number. We have the is, which is equals 17. So we have the sum. The square of a positive number is going to be x squared. 3 more than, so that's plus 3, the number. The square of 3 more than a number would be x plus 3 squared. So there's our sum of the square of a positive number and 3 more than the number. The square of 3 more than a number is 17. What is the number? So this gives us a quadratic equation to solve. I need to simplify first. X plus 3 squared is x plus 3 times x plus 3. So if I multiply that out, I would get x squared plus 3x plus 3x plus 9. I'll combine like terms. That gives me 2x squared plus 6x plus 9 equals 17. I'll subtract 17 on both sides so that I can get all the terms onto the same side. And that gives me a negative 8 equals 0. Then I'm going to start to solve this. I can see that all of these terms are even, so I can factor out a 2. And then I can factor more. X times x is x squared. 4 times 1 is 4. And I want a positive 3, so I put a plus on the 4 and the minus on the 1. I can set each one of these terms, each one of these factors equal to 0. Subtract 4 on both sides to get x equals negative 4. Add 1 on both sides to get x equals 1. And if you remember in our directions, specify that our number is positive, so we're only going to keep x equals 1 as the solution. Solve the following inequality. Graph the solution set and write an interval notation. So we have the inequality x plus 1 is less than 7. X plus 1 is less than 7. We solve this just like an equation. We're going to subtract 1 on both sides. The only difference is if you ever divide or multiply both sides by a negative, you have to reverse the inequality sign. We didn't have to do that in this example, so we have x is less than 6. To graph that on a number line, we would mark out the 6 on the number line. We would use an open circle because of our inequality here. We don't have an equal sign, so we don't want to include that point. And then we're going to shade the values that are less than 6. So that would be our graph. And that looks like this one right here to me. And then our interval notation, we always look at our shaded region on our picture. And we're going to choose the lowest value shaded. Since this is a number line, this end goes on forever. So our lowest value is negative infinity. Our highest value will be 6, and we use parentheses next to the 6 to indicate that 6 is not part of the set. So that's our interval notation. This one says solve the following inequality, graph the solution set, and write the interval notation. So we have x minus 3 is greater than or equal to 2. So to solve this, we would solve it by getting x by itself. So we add 3 to both sides and get x is greater than or equal to 5. If we ever divide or multiply by a negative, we want to reverse that inequality sign, but we didn't need to do that here. So on our number line, we would mark out where 5 is. This time we're going to use a filled-in dot. And we want to shade greater than 5, so that's going to be to the right of 5. So that looks like this one right here. Our interval notation, we're going to have a lower bound of 5 and an upper bound of infinity. Parenthesis on infinity always, and we're going to use a bracket on the 5 since 5 is included in the set. In this graph, in this example, we're going to sketch the graph of y equals 1/2 x cubed by plotting points. And we've been given some points to plot here. We've been given the x's. We want to find the ordered pairs for those x's. So if x is equal to -2, y is going to be equal to 1/2 times -2 cubed, 1/2 times -8. And that works out to be -4. So we would write the ordered pair -2, -4. And we can plot that, -2, -4, would be about right here. Okay, if x is equal to 0, y is equal to 1/2 times 0 cubed. Following order of operations, 0 cubed is 0, and 1/2 times 0 is 0. So we get the ordered pair 0, 0. Right, then we have x equals 1. So y is equal to 1/2 times 1 cubed. That's 1/2 times 1, that's 1/2. So 1 and a half is my ordered pair, 1 and a half. And I have x equals 2, y equals 1/2 times 2 cubed, 1/2 times 8, and 1/2 times 8 is 4. So we have the ordered pair 2, 4. That would be here. So we're going to get our curve to look something like that. It has a little squiggle in the middle. Find the x and y intercepts of the graph of the given equation, 4x minus 5y equals 12. So we're going to find an x-intercept by letting y equal 0. So that's 4x minus 5 times 0 equals 12. 4x equals 12, divide by 4, and x equals 3. I like to write my x-intercepts as ordered pairs, 3, 0, but if I look in my directions here, it says to enter them as integers or fractions. So we would just write x equals 3 for our x-intercept. Now we find a y-intercept by letting x equal 0. So that's 4 times 0 minus 5y equals 12. It's negative 5y equals 12. Divide by -5, and y equals negative 12 over 5. So that's how I'm going to write my y-intercept, negative 12 over 5.